This video is the first in a series of videos to describe the web software known as PMKS. You can access PMKS at any time by the link at the bottom of the screen, http://perl.org/PMKS/. Don't forget that last slash. In part 1, we look at the capabilities of PMKS. PMKS stands for Planar Mechanism Kinematic Simulator. In the remainder of the video, you will see the workings of PMKS in real time. Here we're clicking on a URL. It's opening a web page. This is a Silverlight app, and this simulation of this 4-bar runs on your computer, not on a server. You can open, you can save, you can get this particular 4-bar as a URL. You can stop the time playing and scrub through time, move through time, and see the 4-bar mechanism at any point in time. You can actually grab a link or a joint and move it, and in real time see the path it's creating. So here I'm dragging a point on the ternary coupler of the 4-bar. I can move any link. Notice by changing the ground link that drastically changes the shape of the curve the 4-bar makes. I can also change the speed. Here I'm changing the speed from 10 RPMs counterclockwise to 5 RPM clockwise. Under the edit commands here, it gives the details of each of the joints, each of the black dots that is moving around on the screen. I can show position, P, or I can show velocity or acceleration. More on that in a minute. In this second animation, we're showing a 3-position synthesis. One of the things you can do in PMKS is indicate positions by those gray shapes there. Now I'm going to look at the path generated at the end of the grounded links of the 4-bar, and you can see they make circular paths. Well, that doesn't exactly match through those 3 positions, but if I move this ground link, careful to pass through the 3 blocks shown of the 3-position synthesis. There we go, something like this. I don't have simply just revolute joints at my disposal in PMKS. I can simulate RP joints, as shown here between the pink and blue, and P joints shown between the green and ground. Here, by changing the ground location, I can get all sorts of different paths again dynamically. Notice the yellow and red lines showing velocity and acceleration. If I want to get a more detailed view of that velocity and acceleration, I can click the Export Kinematic Data button, and that'll save my data to a large text file, which I can then open in Excel and make plots of various things. For example, velocity, x-velocity as a function of time. So I can do revolute joints, slider joints, RP joints. I can even simulate complex mechanisms like the Stevenson 2, which does not have a 4-bar connected to ground, and even move one of these links around to see the path that it creates. This is a pure kinematic simulation. There's no forces being calculated. The good thing about that is the user doesn't have to calculate or predict masses or friction or stiffness. PMKS can even solve elusive mechanisms like the double butterfly mechanism, which is shown next.